So we're on unit 4.5. Okay, and we're going to be dealing with parabolas in descriptive form. Parabolas in descriptive form. Okay, so a descriptive form parabola is written in y equals a times x minus h squared plus k form. Okay, y equals a times x minus h squared plus k form. Remember that a value, the a value tells you if your parabola is going to be opening up or down. So if your a value is positive, what does that tell you? Does it open up or down? If the a value is positive, then your parabola opens up. If the a value is negative, what does that tell you?
Parabola reminds me of Ebola.
Your parabola opens down. Thank you for sharing. Also, from here, you can tell that your line of symmetry, the line of symmetry is always equal to x equals h. So all you have to do for line of symmetry is change the sign. Okay, line of symmetry, you have to change the sign. Okay, line of symmetry. To find the line of symmetry, all you do is change the sign of whatever's in the parentheses and make it an x equals equation. So change whatever sign in what's in the parentheses and make it an x equals equation. The last part that you have to know from here is the vertex. Okay, to find the vertex, you change the sign, keep the sign. Okay, so vertex, change the sign, keep the sign. So change what's in the parentheses, keep the sign at the end. Okay, vertex comes from change and keep in your parentheses. Okay, so your vertex is technically h comma k. After that, okay, today we're going to be working on, I'm going to ask you to graph, label line of symmetry and vertex, graph, label line of symmetry and vertex. So for example number 1, I would like you to graph and label the line of symmetry and vertex of y equals 2 times x plus 1 squared minus 4. So graph, label the line of symmetry and the vertex. Graph, label line of symmetry and vertex. So, first thing you want to look at is the a value. Okay, the a value here is 2. So this 2 tells you which direction is this parabola opening, up or down. It's going to open up, and since it's a whole number other than 1, is it going to be fat, skinny, or normal? It's going to be a skinny parabola. No.
How about wide?
Wide and fat are the same thing, except that fractions start with F. Fractions are fat, seems to help people remember. You can call it whatever you want to. Okay, from there, you can also find line of symmetry. Okay, you find line of symmetry by changing what's in the parentheses. So line of symmetry will be at what? X equals negative 1. If you don't write the x equals portion, it's going to be wrong. So you do have to write the x equals portion. If you just write negative 1, that's not telling me anything. I'm looking for an equation, so an x equals equation. Your vertex comes from changing the sign, keeping the sign. So vertex, change the sign and keep the sign. So what would be the vertex of this parabola? -1, -4. So you change the sign, keep the sign. From there, you should easily be able to graph. Okay, so put an XY axis. Line of symmetry is at x equals -1, so remember it does need to actually be a line, and this is just a fold line. Okay, it's symmetric around each side, so label this, so x equals -1. Vertex we said was at -1, -4, so yes, I want you to label this, -1, -4. And then from there, I also want you to sketch this, so we know that it's opening up and it's relatively skinny. If you wanted to make an exactly perfect picture, you could find x-intercepts and y-intercepts. I'm not concerned with perfection here. I just want you to know that it opens upwards and it's relatively skinny. Okay, so it's relatively skinny parabola.
So what is relatively skinny? Would that just be normal or is it like skinny?
This is, I would say that this is skinny. Wide is like super wide and normal is just in the middle. Okay, if you label it, that's good. So I would label this as just write skinny.
Alright, so we should take out the whole like relatively skinny part.
Just make it skinny, whatever's skinny to you, and if you label it, it's fine.
Alright.
That would be great.
So what if you're like
Oh my.
Just label it for me. Okay, the other portion that I want you to find here is, tell me, is this a maximum or a minimum?
Maximum. Wait.
Is this the lowest point it gets or the highest?
Lowest.
Lowest, so that makes it a what? Minimum. Okay, this parabola has a minimum. Okay, a minimum. So this is a minimum value. What is the minimum value at? Minimum at y equals -4. This is directly related to something called domain and range. Okay, domain and range. You will have to find these on all of these parabolas, okay?
why is there a red squiggly around?
Isn't domain always on this?
Yep. This one? That's the line of symmetry. So this is the line that, say it again? Oh, that's at. Minimum at. Minimum at.
Minimum. Okay.
At.
It just looks like.
No.
Okay.
Okay, domain and range. Domain is all the possible x values. So domain is the possible x values. Okay? Is there any limitation to the possible x values you could have in a parabola?
Always.
No, because a parabola, even if it's really skinny, could it eventually get wider and you could get all the different x values? Yes. Okay, for all possible x values, the domain for any parabola, okay, domain for every single parabola is always all real numbers. Okay, so possible x values for all parabolas. For all parabolas is going to be all real numbers. And the way you write real numbers is two parallel lines with an uppercase R. For every single parabola, your answer is going to be all real numbers for the domain. It's not a trick question for every single question I ask you. When I ask you for the domain, it is always all real numbers. Always. Because any x number could be a point on this parabola. Okay, even if it's really skinny, eventually, once you get to like 1,000,000 or 100,000, something like that, it could be any x value of number. The range is the other portion that you need to know about. Okay, the range is the possible y values. The range is the possible y values. Okay, since we know that this is a minimum, what do you know about the y values? Can the y values get any lower than -4?
Yeah.
No. All the y values are these values. This parabola is never going to get any lower than -4. So how would you write -4 and above as an equation? The alligator things, the inequalities, yes. So the range for this parabola would be what? If it's a minimum, you know that the range is always going to be, is it greater than or less than -4? If it's above, does that mean greater or less?
Greater because it's bigger.
Greater than, always bigger, yes. Why? Greater than or equal to -4.
What is the little R with the dollar sign?
That one's called all real numbers.
Okay.
So there's gonna be like negatives in there.
Here? For the all real numbers? Yes. So that means, no, that means any number that you can count.
And then is that like a Z with like 2 lines in it or an R? What is it?
This,
A real with a number
With
sign.
2 R's.
Hashtag
it's
hard.
2 parallel lines with an uppercase R through it. So write 2 parallel lines, so 2 lines like that.
Oh, so it's an
With
R
an
with
up-
2 lines.
Yes.
Why is that?
And that's what I just said. Yes, it's an R with 2 lines.
Well, then other people are saying different things.
Okay, I'm sorry that other people told you different things. Okay, let's try another one. For number 2. Yes.
Come on, man.
4.
Catch up. Oh, wow. Hold on.
Okay, for number 2, again, I want you to graph, label line of symmetry and vertex, and then state the domain and range. So graph, label line of symmetry and vertex, and state domain and range. Of the equation y equals 1/4 times x minus 3 quantity squared. Write this down. Y equals 1/4 times x minus 3 quantity squared. I want you to graph, label line of symmetry, label vertex, and then state the domain and range. So what does the 1/4 tell you? That it's going to be facing what direction? Up. And will it be fat, skinny, or normal? It's going to be fat. Or wide. Sorry. And actually, you know what? I'm sorry. We're going to draw this. I'm going to make that negative, so we're going to draw this down. I apologize. I'm sorry, I changed it. So if you make that a negative, it's going to go down. -1/4, yeah. Sorry. So it's going to be facing down. And it would be fat or wide.
For both.
Then, for the line of symmetry, how would you find line of symmetry? Line of symmetry is x equals what? +3. Okay, you always change the sign of whatever's in parentheses. How do you find the vertex? Vertex, we change it and keep it. What's missing here? What can I add at the end? A 0, right. Okay, so if there's ever anything missing, you can always add 0 or multiply anything by 1. It wouldn't change the equation. So here, what would your vertex be? What's the vertex of this parabola? 3, 0. Okay, vertex is a point, line of symmetry is a line. Then if I asked you to sketch this, okay, your line of symmetry would be at x equals 3, so over 3. Make an up and down line, so x equals 3. Vertex is over 3, up 0, so 3, 0. What direction is this opening, up or down? Down, and it is wide or fat. Say again? Fat, yes. And then would you call this a minimum or a maximum?
Maximum.
This is a maximum. Okay, that has a maximum. Since that has a maximum, how would I find domain and range here? What's the domain of this parabola? What's the domain of this parabola? What are the possible x values? All real numbers. For every single parabola, the domain is always the same. It's always all real numbers. And what is the range? Is it y greater than or equal to something or y less than or equal to something? Less than, y less than or equal to what? 0. Okay, it's always the domain and range, or excuse me, the range always has to do with the y portion of the vertex. Same thing as maximum. Okay, we're talking about the y portion of the vertex. Those are all of your answers for that one. Those are all the answers. I don't know what you're asking me.
Samples.
Like you're on the answer choices on the test. On the answer.
What?
What are the answers to that question?
I asked you to graph, label the line of symmetry in the vertex. So this is the graph, that's the line of symmetry, that's the vertex, that's domain, that's range. Yeah? Okay, I have two more for you guys and then we'll be done. Okay? Next thing we're going to look at is shifting things, okay? Shifting or moving parabolas. So for example number 3, I want you to look back at number 1. Look back at example number 1 and write the equation. Write the equation that would result. Write the equation that would result if moved. Okay, so if you move the entire thing 4 to the right and 3 up. Okay, I want you to write the new equation. So what would the new equation be if I moved the entire equation from number 1, 4 to the right and up 3? So if you look back at number 1, okay, I'm just going to sketch it real quickly. Your vertex was at -1, -4. Vertex was at -1, -4, and its equation was y equals 2 times x plus 1 squared minus 4. Okay, so that was your original equation. Y equals 2 times x plus 1 squared minus 4. And it was facing up and it was skinny. If I shifted this entire parabola, okay, so take every single point on the parabola and move it. Okay, I'm going to move it 4 to the right and 3 up. So if I moved it 4 to the right, that would move over 1, 2, 3, 4, and up 3. What would my new vertex be? What would my new vertex be right here? 3 over 3, down 1. So 3, -1. Would anything change about the width or what direction it was opening? No, it would still be skinny and it would still be opening up. Now I just want you to change the equation. So really, what's the only thing that changes in the equation here? What's the only thing that we really care about when we're writing an equation? The vertex. You just have to change this equation, change its vertex. So you're going to change it to be y equals, how wide is it? How wide was your original equation? 2, right? Nothing changes about that. You're still going to have a 2. You're still going to have something with an x. It's still going to be squared. What do you know about the new vertex? What do you know about the x portion of the vertex? It's a 3, so you change it to be what? -3, and what do you change at the end? Or what do I write at the end? A -1. Okay, the vertex, you always change it and keep it. Okay, so change the sign, keep the sign. All you're doing is changing the equation. You're just changing the vertex from the original equation. So you're just changing the vertex. Okay, we're going to do one more that's like this. So hopefully it shouldn't be too bad. Okay, last one for number 4. If you are given the equation y minus 7 equals x plus 2 quantity squared. Y minus 7 equals x plus 2 quantity squared. I would like you to write a new equation, or write the new equation if shifted They shifted or moved. 1 left and down 2. Write a new equation if you shifted this parabola 1 left and down 2. Write the new equation of the new parabola. So, easiest thing to do is to actually draw this. How could I draw this parabola? How could I graph this parabola? First off, is it in the right format? No. What do you have to do to change the format? Add the 7. So move the 7. Where does the 7 get added to? Is it in the parentheses or in front or in the back? At the end. Okay, so to rewrite this, you get y equals x plus 2 squared, and the 7 is at the end. Okay, we're not doing anything with multiplying here, no foiling, nothing like that. From here, what do you know about the width? How wide would this parabola be? What's the coefficient in front of the parentheses? A 1. Okay, there's nothing there. So there's an invisible 1. So this tells you that this parabola is facing up and it is relatively normal width. What do you know about the line of symmetry of this parabola? Line of symmetry is that x equals -2, and what would the vertex be? Vertex would be -2, 7. So change it, keep it. So first thing you want to do is draw your original parabola. Okay, so draw where we're starting. So our line of symmetry is that x equals -2. My vertex is -2 up 7. So -2, 7. Okay, and is this facing up or down? Is this opening up or down? We said it's opening up and it's relatively normal size. Okay, so not super wide, not super skinny. If you draw your original equation, and I'm going to move this 1 to the left and down 2. So 1 left and down 2. Where would my new vertex be if I moved 1 left and down 2? Where would my new vertex be?
-3 and 5.
Right, so -3, 5 for my new vertex. Would anything change about how wide the parabola is if I just moved everything? Nope, still gonna be the same. Okay, it's still gonna be normal width. So really all I have to do here is change from this equation, I'm just gonna change the vertex. So if you rewrite this equation, it's still gonna be a y equals, what's the width? How wide is it gonna be out front? A 1, okay, you don't even have to really write that. What do you know about what goes inside the parentheses? What's going to go inside the parentheses with the x? We're going to change this to be a +3, okay, because you're going to change the sign. And what goes at the end? A +5. Okay, so all you're going to do is just put the new vertex into your equation. Anyone have questions on how I did that? Questions on how we did that? Okay, homework is just going to be the worksheet. Originally, you guys were doing a book page, and a worksheet, but I changed it, so you're just going to be doing the worksheet. You are doing the entire worksheet. So you're doing worksheet 5, numbers 1 through 17. Okay, worksheet 5, number 1 through 17 for homework. If you get some done today and you have any questions, get started now so that if you have any questions, I can answer them in class.